The limit comparison test is a slightly different version of the comparison test. You won't find use for it that frequently, but sometimes it's good to have on hand. And the way it works is instead of looking at the terms individually of two series, both of these series have positive terms, what you do is you look at the ratio of their terms, and you look at the limit of the ratio of their terms. If the ratio of their terms turns out to be a finite number, that's condition 1 here, then what that means is both series either converge or diverge. So if you happen to know the convergence of B, then you'll know the convergence of A. If you know that B diverges, then so does A. If you know that B converges, then so does A. Now, if that limit of the ratio of their terms turns out to be 0 or infinity, then essentially what you should have intuitively is that A is less than B, is essentially the idea. And so what ends up happening is if your B series converges, it's bigger and it forces A to converge. But if your B series diverges, then your A series diverges in the other case. So this is a good thing to have on hand, as I said, and it happens on occasion that this is the right test to use. Let me give you just one example. You can cook up others as you might like. And the reason why this example is kind of handy is because you might want to compare this, do this with a regular comparison test. Let's compare this with a series we know. Just looking at it, it looks like this series probably converges because that denominator gets really big really quickly. You would therefore say, hey, I'd like to compare it with this geometric series. This geometric series converges. It's geometric with r equal to 1/2. So that would be the thing you'd want to compare it with. But if you go ahead and you look at the terms, right away, well, I've subtracted something. So this guy, I've subtracted something from the denominator here. That makes the denominator smaller, which makes the overall fraction bigger. So the regular comparison test would say, this guy's got to be bigger in order to force convergence of this guy. Now, there's some tricks you could pull. Instead, compare it with a different geometric series. But the limit comparison test here says just what you need. So the regular comparison test is uninformative. So let's try the limit comparison test. The limit comparison test says, let's take the limit as n goes to infinity. We're interested in the convergence of this series. Let's call that our AN series. And we're going to use this series, the BN series. And we're going to want to compute this limit. Great. A little bit of algebra. And a little bit more algebra. Let's take out that common factor of 2 to the n out of the denominator. Those 2 to the n's cancel. And now I think we're in great shape. You'll notice, hey, this term here in the denominator goes to 0 as n goes to infinity, so this goes to 1 over 1, so the whole work is equal to 1. And so both series converge or both series diverge. Since the Bn series, the 1 over 2 to the n, the geometric series converges, then both series converge. Pretty handy, and that's basically how the limit comparison test works.